All right. Linear functions. So graphing linear functions. I'm going to graph them by hand. We're going to graph them with the calculator mostly. Okay. I'm going to do both with this. But when we're graphing linear functions, it's going to be in this slope intercept form is how we normally have those. So that's slope hyphen intercept form. The slope is the number that's in front of x. The plane number that doesn't have a variable, that's your y-intercept. Slope is also got some other names. Sometimes it's called rate of change. And when we're counting that, a lot of times we'll count it as rise over run when we're counting that if we're going to graph by hand. And like I said, I'm going to graph some by hand. I'm going to graph with the calculator as well. So most of what you're going to graph, you're probably going to graph with the calculator. But we need to be able to graph some by hand a little bit. Okay, the domain and the range, if you're in slope intercept form, the domain is going to be all real numbers. If you're in slope intercept form, the range is going to be all real numbers. There are some special linear equations that happen, and we'll talk about those in just a minute. But for the most part, if you're in slope intercept form, that's going to be your domain and your range. You don't have they're always that. Okay, so let's graph a few equations and identify the slope and the y-intercept. Okay, so graph the function, identify the slope, y-intercept, domain, and range. So a lot of things there, but the domain and range, if we're in slope intercept form, should be gravy. So here's our function. F of x is equal to 2x plus 6. So when I look at that equation, what is the slope? 2, positive 2. What is the y-intercept? 6. Okay. So when I go to graph that, if I were going to graph this by hand, I'm going to graph it by hand first, and then we'll graph it with the calculator. Draw myself a little coordinate plane over here. Doesn't have to be real big. I think I drew it way bigger than it has to be. I'm going to count up to 6 on the y-axis. 1, 2, 3, 4, 5, 6 squares. I'm going to put me a dot. And then my slope is positive 2. So positive slope goes up and to the right. So I'm going to count from that dot. I'm going to count up 2 blocks over 1 block. Because if you write the slope as a fraction, 2 as a fraction, you can write it as 2 over 1, right? So I'm going to go up 2 over 1. Up 2 over 1. One of the advanced techniques is also being able to count from your y-intercept and go to the left. To count and stay in that same line and go to the left, I'd have to go down to left 1. Okay? Down to left 1 gets me on the same line. And then I could connect those with a line. I'll just use this big sucker. So plotting those points, just a couple points on either side of the y-intercept. Doesn't have to be many. That's doing it by hand.
How did you get the point?
The 6 is my y-intercept, so I started there, 0, 6. And then I counted my slope, which is 2 over 1. So I go up 2, right 1, up 2, right 1. I could keep doing that forever and stay on that line. But I could also count down 2, left 1, and it's also a positive 2 slope.
Okay.
Because negative 2 divided by negative 1. If I go down 2, that's negative 2. If I go left 1, that's negative 1. Negative 2 divided by negative 1 is still positive 2. So that's why that works that way. Now I'm going to graph it with the calculator. On the calculator, I'm just typing in 2x, 2. X is right beside the green alpha button, plus 6. I'm going to hit zoom 6 to reset my window to 10 by 10. That looks a lot like the same picture I just drew. Okay, we can see it crossing the y-axis at 6. If I count my slope up 2 over 1, that's the same slope out of that. Okay, so graphing it by the calculator is absolutely fine, but know what the slope and the y-intercept are. Domain and range. Since we were in slope-intercept form, domain is all real numbers, and range, all real numbers. If you wrote it in set notation, or the words all real numbers, all of those mean the same thing. And again, I don't know which way the final exam will do it because they ask for all of them. You got to know them all the different ways of writing that. Okay, that's not too difficult. Maybe a little bit rusty about doing it by hand, but it's not hard to do. Let's get us another one here. Example B, I'm going to ask us to do the same things for g of x, so that's just a different name for the function. Let's do negative 3/4 x minus 5. Okay. So my slope is what? Negative 3/4. So that's going to be down 3, right 4. My y-intercept, negative 5. So I'm going to get me a coordinate plane here. I need to make sure that it goes down to negative 5 at least, and a little bit further if I'm going to count my slope the right way. Trying to line that up just right. There we go. So I'm going to go to my y-axis. I'm going to go down to negative 5, and I'm going to put my dot. 1, 2, 3, 4, 5. There's my y-intercept at negative 5. Then my slope is negative 3/4, so I'm going to count down 3, right 4. And I could also count up 3, left 4, and it'd be the same line. Okay, just flipping the sign there. So down 3, right 4. 1, 2, 3, 4. I could also go up 3, left 4. That's also, and notice how it gets it in the same line. And then we're drawing that line, connecting those with a nice little straight line.
I have a question.
Yes, sir.
I can't see this. Just pass a little bit. Is the slope not negative 3/4?
It is.
Okay, how do you determine
Which way to go?
right if the negative?
All right. So I always put my negative with the top number to start with. So I put my y-intercept right there at negative 5, and then the negative 3/4 slope. The negative with the top number. That's my rise. So I'm gonna go down 3, and then the 4 is gonna go to the right.
So the 4 is positive?
Yes.
You treat it like it's positive?
Yes, that's right. Only one of them can be negative at a time.
Okay.
So if you treat the 3 as negative, then the 4's got to be positive. But to go the other direction, when I counted the other way, when I counted from here to there, I made the 3 positive and went up 3, but I had to make the 4 negative to stay on the same slope.
Okay.
So the negative has to be one of them. It can't be both of them. It's only one of them.
So I guess technically you get the same thing as long as one of them is, either one is negative.
Yes, that's absolutely correct. That's exactly right. Perfect. That's the right idea. As long as one of them is negative, you're good. And then, so we're connecting those with the line. That's what I was doing. Yeah. I found that little ruler for. And there we go. If I graph that with the calculator, let's do that. Y equals. So I'm going to use my fraction button. So alpha y equals the fraction. I'm going to put the negative with the 3 up top, and then press the right arrow key and then put the x beside it. Make sure the x is not down in the bottom with the 4. And then minus 5. And there's that line going through the -5 and having that slope to it. Positive slopes are always going to look something like this. Negative slopes are always going to look something like that when you read them left to right. Positive slope goes up and to the right. Negative slope goes down and to the right. Okay? That can help you make sure you go in the right directions. Okay? What's the domain and the range? All real numbers. I'm just going to write it in interval notation. And if you want to write it in the other notations, you can. Because we've done that quite a bit today. All real numbers. We were in slope-intercept form, that's why. Okay. All right. Let's look at example C. F of x is equal to +3. Now, notice that it doesn't have the mx plus b format. But it still has a slope. And it still has a y-intercept. If I wanted to write that in slope-intercept form with the mx plus b, the +3 is going to be the plus b. So my y-intercept's 3. What's the slope if it's not there? 0 if it's not there. So the slope is 0, which is going to be a horizontal line. When the slope is 0, it's horizontal. Okay? So this is like one of those from the lab 7 that we did earlier today. So when I go to graph that, all I've got to do is go to 3 on the y-axis, put my dot, and then if my slope is 0, think about it as going up 0, right 1. Yeah, it ends up creating this horizontal line. They're all technically straight lines. This one's happened to be a horizontal straight line. So slope is 0. The y-intercept is 3. So when it's y equals a number, horizontal line at whatever number that is. Now, this is a special case. What is the domain and the range? Domain is all real numbers. What's the range? Just 3. So the way we write that in interval notation is just brackets with 3 inside, or y such that y is equal to 3. So that's a special case. So whatever the y value is there, that's where your line is going to be. That's going to be the only number that's in your range. Skylar.
Every time you have a slope, are you always gonna put 1 under it?
Yeah, if it's a whole number, I always just put 1 under it. That way it gives me a run to do. Sometimes the slope is a fraction and it's already got a number down there. But if it's a whole number there, I'm going to put 1 underneath it. That's a habit that's pretty good to have. It'll help you with the rise over run stuff. So this is a linear function. It passes the vertical line test. The next one is not a function. And this came up in the lab we did earlier today, which is why it kind of is one of those labs that I like to do before we do this lesson. This is definitely not slope-intercept form. But it still has a slope. And it still has a y-intercept. Well, it doesn't have a y-intercept. It has an x-intercept. The x-intercept is at -4. Does anybody know what the slope is called when there's not a slope? Like when it's not in slope-intercept form. There's no way to write this in slope-intercept form because there's not a y. It's called undefined slope. It's going to be a vertical line. Undefined slope's a vertical line. So when you go to graph this, get your coordinate plane drawn. Yeah. You're going to go to that number on the x-axis. I'm going to go to -4. Yeah. Put my dot, and I'm going to draw a vertical line right there. Goes right through that point. That's technically rising any number over and running 0. Rise over run is something over 0. 0 under the line is undefined, is the way I remember that. But x equals a number is going to be a vertical line. We saw this on the lab that we did on lab 8 when we were doing the different pictures. That's not a function, but it's linear. That's why it's in this section. It's linear. What's the domain of that thing? -4. Or all x's as long as x equals -4. That's different ways of writing that. What's the range? Yeah, all real numbers, -infinity to +infinity, whichever way you want to write that. Be able to write it in all the ways, but so that example C and D are those special case problems that we deal with. Okay, so those are special cases. Let's do one. Let's go example E here, and they ask us to graph 3x minus 7y equals 14. So they asked me to graph that thing. So when I look at that, what do I notice about it? Not in slope-intercept form, and it has x and y in it. So that means I can get it into slope-intercept form. So this is where this connects to the literal equations that we did in 1.1. Let's get y by itself. So we want to solve that for y. So step 1 is solve for y. So how do I solve that for y?
Subtract 3x.
Minus 3x, that's a good start. And I'm going to write it in the right order this time, -3x plus 14. So put the x part in the front. If you want it in slope-intercept form, the x part goes in the front. So a little bit more picky on this section. Now, one more step gets y by itself, which is what we want. Dividing by -7. So everybody gets divided by a -7. So that's going to give me y is equal to what? 3/7 x and 2. Yeah. So the negatives there, -3 divided by -7, even though that doesn't reduce, the two negatives cancel each other out. So we get a positive 3/7 slope, and then 14 divided by -7, that's where the -2 is coming from. Okay. Once we get it here, it's just like what we've been doing. We got the slope, 3/7. We got the y-intercept of -2. Okay. So I can put that on the coordinate plane. I'm just drawing myself a little coordinate plane over here. My first dot is at -2. Up 3, right 7. 1, 2, 3, 4, 5, 6, 7. I could also go which way? Down 3, left 7. 1, 2, 3, 4, 6, 7. And there I have graphed that equation. What's the domain of that? Yeah, all real numbers for the domain, all real numbers for the range. because we were able to write it in slope-intercept form. The y equals mx plus b. If we can write it in that form and it doesn't have the zero slope, then it's going to be all real numbers for domain and range. Okay? That never changes there. Let's do one more of those. Say we have 10x, and I didn't graph that with the calculator. Let's do that real quick. I'm going to graph that with the calculator just real fast. Fraction, 3/7. Whoops, not 3 commas. 3/7 x, and then it was -2. Just to make sure we got the right picture. Oh yeah. Yeah, that's the same. We see that picture with the calculator. All right, so 10x plus 30y plus 8 equals 8. So before I start graphing it, what do I need to do?
Subtract 8.
And work toward getting what?
Y on one side.
Get y on one side. So I'm just going to move that 8. That's a good idea. Subtract 8. What happens over there? I got a 0 now. Okay, well that's I don't know if that's fortunate or unfortunate. I'm not sure. We'll find out. Now what?
Subtract the 10x.
Minus 10x. It's a good move. 30y is equal to negative 10x. Technically plus 0, but you don't have to put the plus 0. It's optional because adding 0 doesn't change the problem, right? But maybe it helps us when we go to graph. One more step. Divide by 30. Oh my gosh. Divide by 30. So that's y. Negative 10 divided by 30 reduces to be negative 1/3 x. What's 0 divided by anything? 0. So technically, negative 1/3 x plus 0. So the slope is negative 1/3. My y-intercept is 0. So I have a slope and a y-intercept here. The slope is not 0, but the y-intercept is. So this one has all real numbers for domain, all real numbers for range, because I was able to write it with a slope and a y-intercept there. Now I'm going to go graph it on the coordinate plane. So let's do it. Oh yeah. So there's my coordinate plane. Where do I start? 0, 0. So the origin is my y-intercept. And now what? Down 1, right 3. I could do that a couple of times, or I could go up 1, left 3. As long as one of them is negative. And then there's my line. Either of those I would count correct, but probably on the multiple choice stuff that you're going to see, it's not going to have the plus 0 on there. They're not going to write that. I think it's helpful to have it, but you don't have to have it. Again, domain and range, all real numbers. Let's graph it with the calculator just to show that we can. I'm going to put the negative in front and then do my fraction button just to change it up, show you it's the same thing. There it is, crossing the origin at 0, 0 with that negative 1/3 slope. So being able to graph it with the calculator is probably the easiest thing, but be able to do it by hand too. We need to be able to do some stuff manually, just in case robots take over the earth and we have to ditch all our technologies. It's coming, guys. AI. It's coming. All right. Last thing. So last several examples here. Find the slope of a line connecting 2 points. To do that, you need the slope formula. The slope formula is this: y2 minus y1 over x2 minus x1. So you have two ordered pairs. You have x1, y1, and x2, y2. You have a first ordered pair and a second ordered pair. That's where those y2s and 1s are. They're not exponents, they're subscripts just to note, hey, that's the second y value, that's the second x value, that's the first x value, first y value, the 1 and the 2. Okay? All right? Very, very important formula. Commit it to memory. You will use it quite often. Okay? So make sure you got that. If you write it every time I write it today, you'll have it memorized. Sir.
Is that an addition sign between them?
No, that's an and. That's my shorthand for and. Sorry. My shorthand is not what everybody's shorthand is. Sorry. That's word and. So it's just two ordered pairs. The two ordered pairs we have. So let's get an example of doing that. So we're going to find the slope of the line between 2 points. So slope of the line between -4, +8, and 2, -3. Okay, so those are my two ordered pairs. So I want to find the slope between those two lines. So I'm going to take y2 minus y1 over x2 minus x1. Like I said, if you write the slope formula as many times as I do, you'll have it memorized. You won't have to work it memorized. You'll have it in the bank.
So, -3 minus 8 and 3 minus -3.
All right, so it doesn't matter. Yeah, -3 minus 8. That's our y values on the top. The x value that goes with -3 is 2, and then minus -4 on the bottom. So -3 minus 8 is -11. What is 2 minus -4? 6. Then you try to reduce that fraction if it will. Well, 11 and 6, they don't go evenly, right? Is there anything that goes into 11 that goes into 6? No. So that is my slope. The nice thing about the slope formula is you can do it in the other direction. If I did 8 minus -3 over -4 minus 2, on the top, I'm going to get positive 11, and on the bottom, I'm going to get -6. Is that the same fraction?
Yes.
Technically, yes. Because if one of them's negative, the whole thing's negative, right? So -11 over 6 is equivalent to positive 11 over -6. So
Sure whenever you put the ordered pairs, like they're on top of each other.
that's exactly right, Haley. Make sure when you put your ordered pairs, it doesn't matter what order you do them in, whatever y value you start with, make sure the x value is underneath it. So if I start with the -3 y value, I got to make sure 2 is underneath it. If I start with 8, I got to make sure the -4 is underneath it. So it doesn't matter which one you start with or which one you call x2 and y2, which one you call x1 and y1. It doesn't matter as long as you get them in order the same way, x's and y's. Okay. Example H. Let's do these two ordered pairs. 10, -6, and 8, 4. So we're going to find the slope. y2 minus y1 over x2 minus x1. Writing that dang formula again. You need to know it. So pick whichever y value you want to start with. I'm going to start with the 4. 4 minus -6 over, because I started with the 4, I have to start with the 8 on the bottom. Make sure they're together up and down. And then, so the 8 minus 10.
Can you remember -2?
So Positive 10 over negative 2. Does that reduce
Yes.
to negative 5? Boom. That's my slope. That's not bad. Pretty easy to do. If you did it the other direction, you would have negative 10 over positive 2, and that's still negative 5 when you reduce it. So it doesn't matter, again, what order you do that in. It's going to equal the same thing. The signs are going to take care of themselves. But you just got to make sure you got y's on top, x's on the bottom. This is example I. 5, negative 3, and 2, negative 3. So there's my two ordered pairs. Again, slope formula. y2 minus y1 over x2 minus x1. Pick you a y value to start with. Good news is I can't screw this one up. Negative 3 minus negative 3 over, I'm just going to do 5 minus 2 because that's easier. What is negative 3 minus negative 3? 0. 5 minus 2 is 3. What is 0 divided by 3? 0. What do I know that line connecting those two looks like? Well, they're all straight lines. Horizontal line. Yeah, that's a horizontal line is what that looks like. 0 slope is a flat horizontal line. 0 on the top. That's when that happens. Last example of the evening, folks, and it's 6:20. We're going to get out of here before 6:30. All right, so here's our ordered pairs. 2, 7, and 2, negative 18. So again, slope formula. y2 minus y1 for x2 minus x1. Negative 18 minus 7 over 2 minus 2. Negative 25 over 0. Can you break 25 candy bars into 0 pieces? No. That is undefined. The way I had Miss Patricia Campbell, I don't know if anybody knows Miss Patricia Campbell. She works at SCA at Sharon Christian Academy over in Savannah. She's gone to church at Sharon Baptist forever. She was my math teacher in 8th grade, 9th grade, 10th grade, 11th grade, 12th grade. Same math teacher. Went to Advil. We didn't have any. But she taught me this. She said the way you remember that is 0 under the line is undefined. And I have remembered it that way since the 8th grade. So that helps us there. So undefined slope is a vertical line. So remember that. 0 slope's horizontal. Undefined is vertical. That's handy to know. If you've got the textbook and you want to do some practice problems in section 1-1, 1 through 41, and then 49 through 65, odds would be good practice. In section 1.2, 1 through 25 odds would be good practice. In section 2.4, which is what we just did, that would be numbers 1 through 61 odds would be good practice out of that. You don't have to do any of those, but that's just good practice for you. If you borrowed a calculator, please return it to me before you leave. I will send out the thing. You got 3 quizzes for this stuff. And we'll do 2 labs next week. I'll send all that stuff out tomorrow in the announcement. Appreciate you being here. Y'all be safe going home. Roads are wet, so we hadn't had that in quite a while, so we may be out of practice.
Thanks.
Yeah, thanks. Keep recuperating. If you need anything, let me know.